I think I pushed the enter button instead of the record button. Okay, anybody still need a second here? All right, my last function we're going to talk about is quadratic. Now, if I had to give a major topic of Algebra 2, this would be it. Quadratics is where we're going to spend the majority of your time. Do you think that would be accurate, Maddie? No?
Well, I don't know. I failed.
You didn't fail the whole year.
I'm sorry, half the year. The half we did this.
Okay. I won't. Okay. Quadratics is the major emphasis of Algebra 2. We're going to do other functions. We'll do exponentials, logarithmic, trigonometric, and all those. But quadratic is the main thing. Do you remember what the graph of a quadratic makes? What its shape looks like? It's a U. What's the math word for that? Good job.
Parabola.
Parabola. And some people do say parabola.
I say it like that. Don't judge me.
But that's fine with me. I just always say parabola. So the parent function, a quadratic, is always squared. That's what makes it a quadratic. And then the parent functions, we always start a parent function at the origin. So if I plugged a 1 in here, what's 1 squared? 1. So I would go right 1 and up 1. What about a negative 1? What's negative 1 squared? It's also 1, because a negative times a negative is positive. So I would go left 1 and up 1. Now, with just those points there, that looks just like the absolute value function, doesn't it? So it's up to you to know what you're dealing with. Did this have the bars on it and draw a V, or was it squared and make it a U? You have to make sure you're drawing intelligent. We know it's quadratic, it's squared, so this should have a round to it. Beautimous. Now, I will tell you this. What we're going to start working with today on these transformations, we're going to do all year long. And every type of function we talk about, we're going to transform it. And slides, reflections, flips, oh, that's a reflection, rotations, all stretch, shrink. We're going to do that all year long. Okay? So it's important that you start getting this today. And I'll tell you, quite honestly, it's not going to click for everybody today. But you're going to see it a gazillion times, and it's going to eventually start clicking for you on how these are going to start moving around. Right now, y'all are like, well, we hadn't even moved anything yet. We're fixing to. Okay? We ready? Ready, Freddie? Sure wish my iPad, my doogie was working. All right, I'm going to start us off simple. Start you off with the simple one here. This is just going to be a no-brainer. It's supposed to be an F. We don't want to do that yet. But we will in a minute. Alright, so that says the absolute f of x equals 2 times the absolute value of x plus 1. Here's how easy my question is about this. Identify the family to which that belongs. And you wrote down the name of 4 families. You wrote down constant, linear, absolute value, or quadratic. So identify the family that belongs to. Don't everybody overwhelm me and answer at once. This is, you get to talking here. Absolute value. Okay? You can spot that by the V shape, or you can spot it by the absolute value bars. Okay? Pretty straightforward, pretty simple on that. Belongs to the absolute value function. Family. Alright. Now, how is this one different from the parent function? Maddie and Hunter's on a good roll over here. It started up at 1 instead of the origin, so it scooted up more, right? I wonder if that is shown here anywhere. This is scooted up 1 from the origin. and we've got a +1 stuck on the end. Yes. Anytime stuck on the end of the function, those are a plus or a minus something, that's a slide. That's a translation is the geometric word. That's a translation up or down. So we got a big fat +1 stuck on the end. It's not in with any of the other stuff, because when we get in with that other stuff, it'll be something different. But just stuck on the end, it's a translation up or down. +1 went up 1. If it was down, -1, it would have went down 1. Okay? Now, you might not can tell from my beautiful picture of the graph, but look at the function I gave you. Look at the equation. What else is different from the parent? Yeah, y'all are whispering it. Quit being scared. Y'all, I showed you a video of me humiliating myself. You can talk out loud. It's got a 2 out in front, right? So I wonder what that 2 out in front could mean. Any guesses on that? It has, kinda. It has to, because since this is an absolute value function, it kind of, I think it kind of opens up, you know. So when you've got something out in front like this, this has to do with how wide or narrow it opens. Okay, so I wonder if this 2 made this wider or more narrow than the parent. You got any guesses? Hearing some widers. Do we have any from the narrower bunch?
I'll say it. I don't know about it, I'll say it.
She didn't say what I wanted to say.
So when you go over 1 and up 2, make the B.
Over 1.
And up 2. The first point.
If I, from this point,
Go over 1 and up 2. So you do like that, and you put your arrow straight up.
what? So,
And then you do that.
okay, yeah. What I would do to make sure on that is I'd plug, because this is over 1, so I'd plug a 1 in here. So absolute value of 1 is 1. 1 times 2 is 2. And then you got a +1. So this would be up 3. And so you were right, because this was already up 1. So you were right on that. So that's the 0.13. I like that thinking, Garrett. That was pretty good. Okay, let's go back to the narrower or wider, though. Do you think that thing got... I know it's hard to tell from our pictures because we didn't measure or do anything. But we got to figure out if that number out in front makes it narrower or wider.
It'd make it wider, wouldn't it?
It'd be narrower, wouldn't it?
It is narrower. Which, that goes against your gut feeling. Because the gut feeling is, we put if there's no number out there, it's an understood 1, correct? We made our number bigger, so it must have got wider. That's what your gut says. So it's the opposite. The number is bigger than 1, it gets more narrow. And this is called, you know, there's lots of different letters and everything. This is called the A. So if the A is greater than 1, it gets more narrow. If the A is less than 1, it gets more wide. Now, what kind of number would be less than 1? Be a fraction or a decimal.
Like
Because,
0.5.
good. Because that negative in a little bit, Hunter, is going to mean something totally different. It's going to have to do with... So all we're worried about is the absolute value of the number, not necessarily positive or negative. All right. We're getting our feet wet. We're jumping in. Let's look at, anybody still need this for a second? See some people that are writing. All right, let's look at, I'll get a piece of graph paper this time just because I can get one real fast, I think. All right, that one. There we go. Let's do, what's that line? I want to do a line. What's the name of this line? What was on there? It's just f of x equals. No, not 1. X. This is our parent function, isn't it? It went through the origin, and it had a slope of 1. So this is your parent function, just f of x equals x. Right? And you've got that down on your parent function. Now I got another little line up under it. I wonder if we know its name. I know it's hard for you to tell from where you're sitting because you can't come up here and touch this. But I counted on every one of these lines. Usually I like to count on the red ones, but I didn't have enough room. So from this point that I made here, that rose 1 and ran 1. Rose 1 and ran 1. Rose 1 and ran 1. So its slope is also 1, correct? So its x is also just going to be a 1x. But it didn't start at the origin. What did I do to it? Where did it start? What did I do? To get to this point, how would those match up? You want me to count with you? 1, 2, 3, 4. So it went down 4. So how would I show that in its name? What did I tell you an up and down did?
-4.
Very good. Just sticks on the end. So this type of question that we're going to talk about here with this picture shows up when we start talking about tests in here. This type of question shows up a lot. It'll say describe the transformation from the parent to the new one. So you would say, you could use the correct geometric word. It translated 4 units down. Or I'm easy going. I could say it moved 4 down or it slid 4 down. I'll roll with that. Sometimes they'll give you the picture of the graph and you got to do just what I just did and count out everything. Make sure they still had the same slopes. And then just see how much it moved. So I should just be able, sometimes this fancy stuff will let me do this. I should just be able to take this line and scoot it up 4. And look, it's exactly the same. Right? So you can see that it was just a down 4. So sometimes they'll give you that, the picture. Sometimes they just give you the names, the equations, the functions. And you've got to be able to look at that function and figure out, like Garrett said, well, it's got a -4 on it. That means it went down 4. Okay? And that works the same on the V's, the absolute values, the U's, the parabolas. A constant, you could take a horizontal line and move it up or down by sticking a plus or minus on the end of it. Okay? Getting some weird looks from yous. I don't know if that's good or bad. Alright. I want to talk about what Hunter said. Anybody still need this for a second? One of the things Hunter mentioned a minute ago. It's a great day. Talking about stuff getting wide or narrow. We talked about if the A was bigger than 1 or less than 1. And Hunter wanted to know about a negative. And so I told all of y'all then, when you're checking to see if it's wide or narrow, you don't worry about positive or negative. You just take the digit, just the absolute value. Did it get bigger or smaller? But now I've thrown a negative. Nothing else changed. The parent's an x squared. This is an x squared. The only difference is that x squared is positive and that x squared is negative. Nothing else changed. But the graph looks way different. Shoot. Yeah. And it just needs to be something, and I didn't close the parentheses on the F. Just needs to be something other than F because it's different. But I did use a P that time for some peculiar P reason.
I was confused. We can't see good at all. So.
Well, I have one of the worst handwritings you'll ever see, so it just compounds it, doesn't it?
Yeah, it's really great.
All right, so that little bitty negative is the only thing different, but it made the graph look way different. So you just learned something. What does a negative out in front of the function do to it? Reflects it. Short word for reflect. Flip. Okay. So we got a negative out. Bless you. If we got a negative out in front of the whole thing, all we do is flip it. So transformations we've discussed so far already in this short lesson so far. We've translated. We've slid. Right. We didn't do a whole lot yet with the wider narrow. We're going to get to that in a minute, but because that's actually called shrinking and stretching, and that's what's coming next. So we'll do shrinking and stretching more in depth here in just a minute. And you just did reflections. And I'm thinking, I could be a little confused, but I'm thinking that's pretty much, we only slid up and down. We got to talk about sliding light left and right as well. So we'll do that in a second. All right. Let's do that shrinking and stretching, though, because that's the fun stuff. I always think about putting you in a tapping machine and shrinking and stretching you. That'd be cool. Wonder if that's legal. That one seems concerned. Just lots of different ways this stuff can be presented to you or written. The directions for this say to graph the function and its parent function and describe the transformation. And that's all I gave you. So is that the parent function? No, because it's not just an X. It's got that extra junk in front of it. So I would go to my notes if I don't know, and I would find the parent function of the quadratic because it's squared. And I would see that parabola started at the origin. And I would know, like, if I put a 1 in the parent function, I would square it. 1 squared is 1, so it would go right 1 and up 1. And you've got this in your notes. You know what the picture's supposed to look like. If I squared a negative 1, negative 1 times negative 1 is also positive 1. And I've got the graph of my parent function. And its name was just X squared.
No, I guess you just half that.
Very good. All we're going to do now to get our H, we're still got to square it, but then you take half of it. Right? So if I did this point, 0 squared is 0. Hold on. 0 squared is 0. What's half of 0?
0.
So that point's going to stay the same.
But the other 2 points would be 0.5.
Okay, this one I went over 1. So 1 squared is 1, and then I take half of it, and that's 0.5 or a half. So I go over 1, and I just go up a half. Is it my lines that confuse you, CJ? I made the red one be 1. I'm sorry about that. I didn't do that earlier, so I should have stayed consistent. Okay, so same thing when I plug a negative 1 in. Negative 1 times negative 1 is 1. Half of that is a half. So before I even draw the U, you can tell it's wider, isn't it? Don't you think that?
Yep.
And didn't we make a little note earlier about if our A was less than 1, it was going to be wider, right? So everything's clicking. Everybody's making good sense on that. Now, I wonder, would we call that a shrink or a stretch? And this is where you're going to get your mind blown. So I pretty much just told you the answer. It is a shrink, and I hate that. Because my brain looks at the blue one and says it got fatter, it got stretched out. That's what how my brain works. But that ain't right. What the math way on this is going to say these points shrunk down. See that? These points shrunk down. So even though that A being less than 1 made it wider, or A being less than 1 made it a shrink. So here it would make it a stretch. Sometimes I think that whenever they had a math party back in the Stone Ages and made up all these rules, they said, I wonder if I can confuse that teacher. I think I should have been invited to the party to straighten those people out. It's got fatter, that's a stretch. Okie dokie, artichoke. Okay, what we're going to look at here, I'm going to put 2 of these, and you can write them in your notes, but then you're going to get up in a minute when I tell you to move and go try something for me. But I'm going to write 2 of these on the board. I got a lot to tell you. Don't go yet. Alright, so I've got 2 g of x functions for you there. Number 1 says g of x equals negative x plus 2. And number 2 says g of x equals x squared minus 2. Okay, my directions for you are going to be, you've got, first thing you got to do is tell me the family that it belongs to. So your choice for that would be constant, linear, absolute value, or quadratic. What family they belong to. After that, you're going to compare it to its parent function and describe the transformation. So for you describing the transformation, just some things we've talked about so far. It's stretched by 2. It slid down 7. It reflected across the x-axis. Those are the transformations. So I'm going to ask for what family, and then for you to describe how it's different from the parent. Okay? There's dry erase markers on the boards, and there's some in your buckets. I want you to find you a spot and just go work. I want you to go take your note paper with you if you're worried about getting it in your notes, but I want you just to go work on these 2 and see what you can come up with. You can go with your buddies, or you can find a new buddy when you get there. Go. I will at some point give you a board assignment, but until I get to know everybody, you can go and work where you feel comfortable. Garrett Riley's trying to stick, I'm sorry, Garrett's over there. I just saw the back of your head. But I did just brain fart and forgot your name. Jason, thank you.
Negative.
That's right. Number 1 would stretch, wouldn't it? Because it's more than 1.
It's kind of just like this one that we did. What family and what did it do to get away from the parent? No, not number 1. That's probably my bad handwriting. That's a plus there.
Oh, okay.
There's not. Oh wait, it's negative x. But that was just that was a you.
We got some good stuff right here. Yeah, let me this is good. This is good. Good. That's right. That's right. How does it look for the lines? It's like what's different? Just move to so if you read left to right, it'll go down. Give me weird looks like you didn't know what was going on. Keep digesting and talk to your group. That's good. Good. Not here. Because that's, oh, it's negative. What is a negative? Let me switch self for words longer. Not a shrink or a stretch. Because remember, this is like a negative 1. So there should 1 there. So 1, it doesn't shrink or stretch. But what does that negative do? So you're so far so good. So the only thing different on this is it's got a minus 2 stuff on it. Where's the minus 2 stuff on it?
No. Wait. It's up. Yeah, it's up in those.
Nope, because this is still just a 1 there. You all right, Bill?
So that was.
I did one more thing too, other than just this. Yeah, not down.
No, it was right. Let's go, B.
Flip and slide too, that's good. All right, good job. What about you up here, River, you good? I'm making my way, just give me a second. Quadratic, yes, that's right. Good job, baby. You all right?
Work. I didn't do it right, B. Let's go.
This did this correct, but it did something else also. This one's got 2.
Oh, yeah.
You've accounted, you've accounted for the move up 2. So now what is different? You're good. If y'all are good, if you're good and you want to clean up your paper notes and head back, you can. I still haven't checked with this board over here.
Wait, so we erase it?
No, that's it.
No, it's not. That's negative.
Did it go that way?
The line needs to go down. Because now that it's still scooted up 2. That's correct. You just didn't get
You
there.
go 1, 2 like that, that. Why would it be like that?
Because it has the negative in front of the X.
So you still go over 1. I just did it. I did it right, but I did it. The line's supposed to be like this, not like this. Yeah. Cause see, I did it like this.
Okay, do this. Take that line up 2 for me. Okay, good. Now it's got a negative in front of it. So all of these have to be the opposite now. So instead of that being over there, it's got to be the other way. So it's going to
Yeah, so I did it wrong. It's supposed to be like this. And you're supposed to go
yes. Yes. There you go.
Wait, you would flip both lines, wouldn't you?
No, don't flip the parent. The parent will
So
always
this one, so this first one right here would be like this,
Yes.
and the second one would be like
Yes.
this.
Good job.
I did do it right. I was just wait, it'll work.
care?
Okay, so I threw you more on number one than I had done with you yet. Because it had, number one had how many transformations?
2.
2. So if I look here, what family does number one belong to? Linear. Y'all are all great on that. So its parent function is just f of x equals x. And you've got that in your notes and you can look up that. Now, I don't do things always like everybody else. Excuse me. Y'all know that? Excuse me. But what I do when I have to start describing a transformation is I just start comparing equation to equation and seeing what's different. So if I read this g of x left to right, the first thing I come to is a negative. And I went and looked over here and there was no negative. So I knew, number one, there's a negative out in front. What does that mean to my graph? It flips. Reflection, some of y'all wrote, that's the mathematical word, that's good, but I'm going to save some smartboard and you can write the short word, it flips. Now for today, everything flips over the x-axis. We're going to learn in the future how to flip it over the y-axis. Okay, but today everything is just flipping up and down over the x-axis. Alright, so I said, oh, that's got a negative, it flips, no negative over here. Okay, keep reading. Oh, I've got a +2 stuck on the end that I don't have here. So what does a +2 stuck on the end do?
Moves it up 2.
Slides it up 2. So I just wrote that. Okay, good job. Now, get really fun when we get 3 or 4 things happening, you know, overload it, but just had 2 that time. All right, so number dos here, what is the parent? Quadratic, and I know quadratic is just x squared. So I'm going to do the same thing. I'm going to read g of x left to right until I find something different. X squared, check, check. -2, no -2. So I did this to that one and not this one. What does the -2 stuck on the end do? Just moves it down 2. Okay? Now y'all did fabulous on that. I'm impressed. I want to show you one more today. Can you handle one more today? I think you can. You're going to. Because we haven't moved anything left to right. I need to move something left to right with you. Alright, so write that dude down. G of x equals 2.2 times the quantity of x plus 2 squared. Alright, kind of looks like we got a lot going on. So I would tell you to take some baby steps and break it down. So first baby step would lead me to the parent. It's a quadratic, hot dog, and the quadratic is just x squared. First thing I notice when I read the g of x left to right, this one's got a 2.2 out in front. When there's something out in front, I said we're going to see the symbol, the letter A for that a lot. So that ought to get your eyes focusing a bit there in your notes. An A out in front of something is going to shrink it or stretch it. So anytime you have a number out in front that's not 1, you're going to be talking about a shrink or a stretch. Okay? Now 2.2 is bigger than 1, isn't it? So what did you write down for its
Stretch. Oh.
I want everybody looking.
It's a stretch. It's a stretch.
Okay? Everybody good? Did everybody, because this is what you're going to have to, and I do most of the time on your tests allow you to use notes most of the time because I'm more worried about you being able to figure stuff out than memorize, so I do allow that, but you got to be able to look in there and find it. So we're all in agreement that that's a stretch. Okay, so and for today, everything is going to be a vertical stretch. We'll get into horizontal later. So we got a vertical stretch, and I can even get real specific. What do you think my vertical stretch is? Did I stretch it by 5, by 10, by 2.2? What do you think my vertical stretch is?
Isn't it 1.1?
No. It's whatever the A is. So this would have a vertical stretch of 2.2.
Why do we have it just a minute ago?
Because
There was
it had a
one
1/2 in
1.5.
front of it.
Oh.
Yeah. Alright, so check, we got that. Now, this next thing we're fixing to find is pretty common, but we hadn't done it yet today. We've had a +2 just stuck on the end, but this one's not just stuck on the end. Do you see how it's included in that quantity? That makes it a big difference. When it's included in the quantity with X, it's going to be moving left or right. Now get ready, don't write it down yet because you're going to guess wrong. Horizontal, that's left and right, that's X. Everybody with me on those words? Horizontal translations always go the opposite way of the sign. Always. Okay? So if this says +2, I normally think, well, plus goes to the right. Horizontal always goes the opposite way of the sign. So this would go left 2 units. I've told my classes in the past about that math party that I was talking about a minute ago. Horizontal had issues. Horizontal got messed up on a lot of things, and this is one of the major things horizontal was confused on. He always went the opposite way of the sign. Okay, vertical got it right. If it said plus, vertical went up. If it said minus, vertical went down. We like vertical. Horizontal's got some issues, kind of like me. Always goes the opposite way. Okay? Okay. You all right? All right. Okay, good news is, those of us that are still confused, it's okay. Because this is what we're still going to talk about some more tomorrow. We're going to zone in and keep practicing on this some more tomorrow. I'm not leaving it yet. But this is going to be the foundation, and we're going to use this all year long on all of our functions. Okay? So I'm giving you a few minutes extra time now. You can get it loaded up and get ready. Unless you got a question for me before tomorrow, I don't mind answering it. All right? All right.